Okay, so I think in the last lecture we looked at beauty of the real line, right? And what else? I mean, the beauty of the real line is there is no hole. I mean, that is the beauty, right? And you need to convince yourself by some arguments that there is no hole, right? And then, and also we talked about countable and uncountable, which is a very useful thing for computer science as well. As I mentioned that it creates Turing barrier, right? Okay, so now I think I have shown you this page earlier. I don't know whether you remember it. This is the online encyclopedia of integer sequences, which basically are very, very important if you want to do any important mathematics. So I think what are these things? Some important patterns and sequences, for example, and I think you see that you will find many people from DIICT have registered sequence on their name. You see, these are 9 sequences. This is, I think, Rachit Agrawal, if I remember it correctly, right? Somewhere down the line, it must be there anyway. Squares of primes, right? This is a new sequence he discovered on his name. So you can have a couple of sequences. But what are these sequences actually? These are sequences of integers, right? So I think in quantitative aptitude, I think if you go give बहुत सारे जो entrance exams है ना उसमें ये questions पूछते हैं quantitative aptitude, right? They have given you first term of a sequence, second term of a sequence, third term of a sequence, and say tell what is the next, right? You might have done those questions. I can give you one beautiful sequence here also. So I think, as you know, if it is 1, 1, 2, 3, 5, what is next? 13. So that is Fibonacci or Hemchandra numbers, right? Sequence. So these are sequence of integers, right? So basically sequences are nothing but a special kind of functions where, so basically if you say sequences of integers means we are talking about functions from natural numbers to natural numbers, right? Sometime including zero, so integers to integers also okay. So I'm saying that natural numbers to natural numbers, right? If you're talking about positive sequences, right? So sequences of integers, right? These are the sequences. So I think I don't know, whenever we start, so it's मेरे को होता है कि कुछ T type problem दे दे, right? So I can give you one small. What is the next term of this sequence? 1, 1, 1, 1, 1, 1, 1, 2, and so on. I have given you 4 terms. You can find 5th term, 6th term, and so on. By the way, of course, this is known. So if you check that encyclopedia I have shown you, you will find the answer. But at least try to see before jumping into the solution, right? What is the next term here? So after that, it will come 3, 1, 1, 2, and so on. Sequences, right? Beautiful, wonderful things, sequences, right? So normally we study sequences from, so these are functions from natural numbers to natural numbers, right? And I am going to talk about sequences which are from natural numbers to real numbers. Okay. So for example, I can say that, so frankly speaking, I denote it by some symbol. I is equal to 1 to infinity. Means this consisting of S1, S2, S3, and so on. Sequences, first term, second term, third term, and all these SIs are real numbers, right? Okay. So one very nice example, by the way, okay, yeah. You know that we have this sequence, right? Then it's equal to 1 to infinity, right? So the first term is 1, second term is 1 by 2, next term is 1 by 3, and so on. If I ask you what happens if we take the limit of the sequence as n tends to infinity. 0. Everybody knows it. Very easy. Now, you should take your calculator out. Phone में calculator होगा ना? Take your phone out. Take your calculator out. Let us do an experiment. अगर साइंटिफिक कैलकुलेटर तो आसान है, थोड़ा सा अदरवाइज थोड़ा सा वर्क अराउंड करना पड़ेगा, राइट? सो यू जस्ट टेक सम कैलकुलेटर आउट. अदरवाइज गूगल पे जो है कैलकुलेटर होता है ना, यू कैन यूज दैट. ओके, सो नाउ टेक सम, suppose we take sequence 1 divided by 2 raised to power n. So I think before, rather than taking 1 by n, I'm taking even much more simpler sequence. Suppose we take this sequence. Right? So the first term is 1 by 2. Next term is 1 by 4. So now can you just do this calculation? Write down these terms on your calculator. Compute 1 by 2. The value is 0.5. Next 1 by 4. The value is 0.25. Just keep on doing. And please keep in mind, count after how many terms. You know that this goes to 0, right? As n tends to infinity. After how many terms you get 0 in your calculator. And these number of terms will be different for which kind of calculator you are using. You see, that is the beauty. See? Just count the number of steps when you get 0. So first will be 1 by 2, second will be 1 by 2 raised 2 square, next will be 1 by 2 cube, right? Anybody got 0? किस कैलकुलेटर की जितनी क्षमता होगी उसके हिसाब से ये काम होगा, राइट? सेम लाइक टू ह्यूमन ब्रेन, जिसके ब्रेन की जितनी कैपेबिलिटी है, सबके पास वैसे इनफाइनाइट कैपेबिलिटीज है, बट यू नो, हाँ, नॉट गेटिंग टू 0. What you are doing? 1 over 2 raised to power. No, it should be n. What you are putting there is wrong. I'm saying that 1 by 2. So the first term is 1 by 2. Next term is 1 by 4. Next term is 1 by 8. Like that. Keep on doing. So first term is 1 by 2. Yes. 2 raised to 329. Then you got 0. Very good. Anybody else? हाँ, अभी तुम देखो कैलकुलेटर की कितनी लिमिटेशन है. आई एम शोइंग यू. ऑल दीज आर इडियट थिंग्स. ब्रेन के आगे सब फेल, राइट? एनी टर्म? 9,000? So can anybody tell why these steps are different for everyone? Any idea? So somebody is using one calculator, you are getting is whatever number he told is a very large number. Somebody is at a earlier you are getting 0, right? Why is that happening? Right? Any idea? नहीं तो कुछ गलत कर दोगे. 1 by 4. हाँ, कैसे बन जाएगा? n tends to infinity लोगे कितना आएगा? यार तुम क्या बातें करते हो, you know? How many of you are getting 1 of answer to this as 1? Anybody getting 1? Impossible, right? ये तो यार जेईई के एग्जाम में क्लियर किया होगा. ये तो सिखाते हैं कोचिंग में कि नहीं? So this class is beyond coaching, right? Anyway, so you will see or you will observe that depending upon calculator, you get 0. Somebody will get 0 earlier. Somebody will get 0 after some time, right? Why is that happening? Any idea on that? This is something important question to ask. Limitation of the calculator. That is okay. But why is, I mean, so somebody might have designed like this, right? What they are doing actually. These are the fundamental basic questions you need to ask, right? Calculator use तो करते हो उसकी limitations भी मालूम होनी चाहिए, right? So you should know what are the limitations. Now, anyway, do another example. Take 2, number 2. Take the square root. And again, keep on doing taking square root to square root to square root. What you will get and after how many steps? 1 आएगा, right? Up to what time? वही तो बताना है, तुम बिना करे थोड़ी, तुम तो यार कोचिंग की फॉर्मूला लगा रहे हो खाली. After 37 steps, you get 1. Okay. So we are just doing square root, square root, square root. Every time there is another square root. Next time another square root. Next time another square root, and so on, right? So depending upon agar calculator, you see that you get 1 in case of square root of 2, square root of 2, if you keep on doing this. So exactly what is happening? Distance. So in the case of 1 by 2 raised to power n, in this example, distance of its terms from 0 is going towards 0, right? So this is going closer to 0 as you are increasing the value of n. Okay, in some cases the value is maybe certain thousand or whatever, depending on which calculator. Some places it is very high. If it is a very good calculator or very high, this thing, I mean, it go very bit far away, when you will see 0. So what is happening is distance between this number and 0 is decreasing every time you are increasing n, right? At least you are convinced with this fact. Similarly, in the other case, like 2 square root of 2, again square root, again square root, that sequence terms are having distance going towards 0 with 1. They are going closer towards 1, right? This is happening. But this idea that in some calculators it is after maybe 500 terms, 500 term it will show you 0. In some 1000, maybe 50,000, whatever, which kind of things you are using, that is a very important thing actually. Everybody knows it goes to 0, but somebody will say that after this term it is 0. Somebody will say that after this term it is 0, right? So this idea has been captured into what is known as limit of a sequence in epsilon and capital N mode. So what is this epsilon business? I'm going to tell you. Okay. Thanks to Bolzano, and I love these things. So again, I will show you that limit of n tends to infinity. I'll take this example as 1 by n. I'll take this example. So limit of 1 by n as n tends towards infinity is 0. You have to show it by epsilon n method, which I'm going to tell you. Okay. So it's a beautiful thing, of course. So see the beauty, okay? So for that, now when I said distance, so how do we define distance on real line? If x and y are 2 points on the real line, distance between x comma y is mod of x minus y. It's a very simple thing, right? You can see that all the 3 properties of distance are satisfied. Number 1, distance is non-negative. Distance of x comma y is non-negative, and 0 if and only if x equal to y. Number 1 condition. Number 2 condition, it is symmetry. Distance between x and y and x is same. So distance between x comma y is same as distance between y and x. And third, it satisfies triangle inequality. These are the 3 properties of distance. The idea of distance is very important. In the whole of computer science, there are different kind of distance you can define. And I love distance. So I think in some of your calculus, the sample papers you might have seen, I have said that use this distance to show that something happens, right? So things are a bit different, right? Okay. By the way, while doing this epsilon delta or epsilon n business, you need to have some, some amount of understanding of inequalities. Inequalities तो पढ़ा होगा जेई में बहुत सारा थोड़ा practice कराते हैं, right? I guess. But I think which book you have looked at? None, right? So there is a very famous book by G.H. Hardy, Inequalities. You can look at it. I love that book. Again, G.H. Hardy, is a famous mathematician. A lot of different inequalities are there, and these inequalities are useful in proving these stuff. So this you should have good understanding of inequalities. Either you understand them, memorize it, make notes, cheat sheet, whatever you want. Right? You need to know the inequalities. Okay. Okay. So let me show you. So I am going to first of all, I will say that limit of a sequence. I'll give you some formal definition. I mean, it's not that formal, but it's okay. A sequence Sn, n is equal to 1 to infinity, has a limit L if Sn minus L is small for sufficiently large values of n. This is a very important statement. When we say that this difference is small, essentially we are saying that the distance between Sn minus L, distance between Sn and L goes towards 0. Right? For sufficiently large values of n. What does that mean? This is very important term. I cannot drop anything here. For sufficiently large values of n. So it may happen for n is equal to 1, 2, 3, up to 10 distance is there. But after certain point, this distance is goes towards 0, right? So let me show you, right? Formal definition, let me give you. And what does that mean? Okay, first of all, what is the limit of this sequence? Every term is 1. First term is 1, second term is 1, third term is 1, fourth term is 1. Then what is the limit? 1. Very good. What about this sequence? 1, minus 2, 3, minus 4, and so on. No limit, right? These are easy things. Coaching में ये सब अच्छे से पढ़ाते हैं, right? Now, I am taking a real line. This is a point L. Now watch it carefully, what I am going to do. Now, L is a point where we want to reach limit of the sequence, right? Okay. And our sequence is Sn. So I'm saying that our sequence is Sn. N is equal to 1 to infinity, right? This is the point. Now what I do, I take a very small positive number, maybe 0.00001 or something like that. Okay. How do I choose epsilon? That is in our hand. Epsilon is a very small number. Okay. So I take this small number epsilon. So this distance is epsilon. This distance is epsilon. So this is an interval of, you can see that one side length is epsilon, other side length is epsilon. Okay. So that means that point here will be L minus epsilon. This will be L plus epsilon. Do you agree? This point will be this, and this point will be this, right? L is a fixed point. I take epsilon positive number. I have added on both sides. On one side it will be L plus epsilon, the other side L minus epsilon, right? Go in this direction, right? So this is the interval. So open interval. I mean, right? Any idea? Any question at this point? Now I take the sequence Sn having terms S1, S2, S3, S4, and so on. If Sn has a limit L, what does that mean? So that means maybe for your calculator, after 10,000 step, everything falls in this interval. And for some other one, after 50,000 step, everything falls in this interval. Before that, where it falls, I don't care. You understand what my point is, right? Before that, where it falls, I don't care. But after some fixed number, it falls within this interval. Now, another very interesting thing, if this guy is saying that after 10,000 steps, it falls in this interval, and for other one, for some other number, so that number also determines the size of this epsilon also, okay? Because, you know, some cases, because if epsilon is bigger, it will take more time. If epsilon is small, you know, it all depends what is the size of epsilon. That will determine the number that you picked up. Somebody calculator is taking some other number, somebody's calculator is taking another. Any idea, any question about this? You understood? This is very, very important thing, right? The first, the behavior of epsilon, and it's beauty of epsilon, actually, I call it. It's a beautiful thing, right? To see that. Now I have to show that that sequence has limit L. That means I have to formulate a definition mathematically, formally, right? What Bolzano has done initially. Okay. So what I will say that the sequence Sn, n is equal to 1 to infinity. I mean, this is sequence of real numbers. Sorry, this sequence of real numbers. Okay. So Sn approaches towards limit L as n tends towards infinity. Right? Sn approaches towards L, point L, as small n. And n is a, you know, the sequence positions, right? 1, 2, 3 terms it is counting. As n approaches towards infinity, if for every epsilon positive means for every number, the size of the interval, right? For every epsilon positive, there exists a positive integer n, capital N, such that mod of Sn minus L is less than epsilon for every n greater than or equal to capital N. In fact, this means if you know the inequality business, that L minus epsilon is less than Sn is less than L plus epsilon. Do you agree? In terms of inequality, right? I mean, this is also saying the same thing, that the distance between Sn and L is less than epsilon for some number, right? It's very, very close, right? And essentially that if you open this inequality, so you can, this means what? Minus epsilon is less than Sn minus L less than epsilon, right? You can add epsilon both sides. So you will get L minus epsilon is less than Sn less than L plus epsilon, right? So the terms of Sn are falling in this interval after some. So now this capital N. So for every n greater than or equal to this capital N, this number n is different for each calculator, right? This n is different. Okay. Are you getting my point? So S1 will be anywhere, I don't care. S2 will be anywhere, I don't care. S3 will be anywhere. Up to Sn, I don't care, right? Or maybe from n. Sn, S capital N will be in this interval. S capital N plus 1 will be in this interval. S capital N plus 2 will be in this interval. Before that, what happens? I don't care. It is inside interval, outside interval, I don't care. Once I fix this capital N, for all small n greater than this capital N, everything falls in this interval. Right? That means the distance between Sn and L is less than epsilon. Right? Any question at this point? Because this is something very, very important definition. If you understand this really well, then you understand the whole business, right? Yes.
if के बाद से बताने के लिए
If for every, अभी आप मैथमेटिशियंस को नोटेशन शॉर्ट हैंड बार बार लिखने में दिक्कत होती है ना, तो शॉर्ट हैंड लिखते हैं. तो क्या है? If for every epsilon positive, So it is saying that you can take, somebody can take epsilon is equal to 0.001. तो उसका जो कैपिटल एन आएगा वो डिफरेंट आएगा. Somebody will take epsilon is equal to 0.00001. उसका कैपिटल एन दूसरा आएगा, right? समझ रहे हो ना? So I will show you with an example also. See, right, how it works, right? Any more questions on this? You understand? If for every epsilon positive, there exists a positive integer capital N such that mod of Sn minus L is less than epsilon for every small n greater than capital N. Okay. This is a very, very beautiful thing actually. Okay. So now you see, I'm going to show you your popular thing that sequence 1 by n has limit 0. How will you show that? Using this definition only. और कुछ यूज नहीं करना है. Formula use नहीं करना है, right? Remember I told you in this calculus class, I am not worrying about calculate this limit, do this, blah, blah, right? Show it by epsilon business. Epsilon you will love and you will remember forever in your life what is epsilon, right? This is such a beautiful thing, right? So now, so I have to show that. So yeah, so I should say that S1 could be here, S2 could be here, I don't care. S3 could be here, whatever, right? But once we have Sn, this belongs here somewhere, Sn plus 1 belongs here, and so on. All other points, so from S capital N, everything is inside the interval. This is something you need to remember, right? Okay, so now I have to show that. So if Sn is equal to 1 by n, I have to show that limit 1 by n is equal to 0 as n tends towards infinity. How will you show that? हमको क्या करना पड़ेगा? Yes.
We already assume the limit to be 0 and then we prove that there is a natural number n for every n.
Yeah, so you have to find that n, right? So all this business is given in Thomas calculus also. I think some of you might be reading or already read. Normally Thomas calculus you can read in 10th class, right? Such an easy thing. Anyway, so what we need to do, what I need to do. So see, first of all, I write down the definition. I have to show that, we need to show that for every epsilon positive, there's a definition, right? We must find n, capital N, such that mod of 1 by n minus 0 is, mod of 1 by n minus 0 is less than epsilon for every n greater or equal to capital N. This is what I have to show, that for every epsilon positive, we must be able to find capital N. My job is to find capital N, after which everything lies in this interval, in the neighborhood. So this L minus epsilon and L plus epsilon is known as neighborhood of L, right? It's a neighborhood of L, right? With epsilon distance on this side, epsilon distance on the other side, right? So, so from this, can I find capital N? It's very easy, right? Your observation. See, as a mathematician, you need to observe. Just observe and observe the beauty, and then you get the answer, right? So, what is the beauty here? So, this says that 1 by n is less than epsilon, because everything is positive, right? Anyway. So, 1 by n is less than epsilon. So, that means n small n should be greater than 1 by epsilon. So, what there I should take? There it says that for every n greater or equal to capital N. So, capital N, I can take any number bigger than 1 by epsilon, and we are done. I have to find capital N. I say that take any number bigger than 1 by epsilon, and we are done. Are you getting my point? Just by observing. Take capital N to be any number bigger than 1 by epsilon. Somebody can take 1 by epsilon itself. Somebody can take 1 by epsilon plus 1 or whatever, 1 by epsilon plus 2. Right? Now, beauty is this. If you vary epsilon, you see the capital N will also change. Right? So if epsilon is getting smaller, what will happen to capital N? Bigger. And if epsilon is bigger, right? So this relationship you need to understand, right? So this number capital N and epsilon has a beautiful relationship, right? So you can control the number capital N by choosing this epsilon. That's why in your calculator, someone's capital N is something, they fix the epsilon, right? So things are accordingly set. Got the idea? Any question? ये तो बहुत आसान काम था. Showing that something exists. ये show करना कि something does not exist using this business is beautiful thing. Right? So how do we show that? Some limit does not exist. So basically, yes, any question? Yes.
कैसे प्रूव करें? तो अगर हम कोई एल ले लेंगे कि ये एग्जिस्ट करता है, बाद में वो प्रूव कर देंगे कि ये एल एग्जिस्ट करता ही नहीं है, पहले एज्यूम करना है कि एल कोई है, पर बाद में वो प्रूव कर देंगे कि वो एग्जिस्ट ही नहीं करता.
पर कैसे करेंगे वही तो
मतलब डेफिनेशन से वो क्वेश्चन था ट्यूटोरियल.
अच्छा अभी देख लिया वो सब. ओके okay, so the thing is that we need to show that, so we'll assume that the limit exists, right, and it is say some number capital L, then you arrive at a contradiction somehow. Okay, and that's a business, right? Yesterday also we have used contradiction business, very useful tool and trick. Okay, assume that limit exists and show that, then somehow arrive at a contradiction. So I will do one example of that kind also for you. So do I need to do this, or I mean, anyway, I can calculate. So this implies that 1 by n less than epsilon. This implies that n should be greater than 1 by epsilon. This suggests that capital N could be anything greater than 1 by epsilon, right? And we are done. Right? Correct? So n, small n should be greater than 1 by epsilon. You take any number. So capital N, I can take any number bigger than 1 by epsilon. It could be 1 by epsilon plus 1, 1 by epsilon plus 2, and so on, right? Anything. And that will do our job. Now we'll do another example. So show that sequence Sn is equal to n does not have a limit. Right? I have to show that this does not have a limit. So how do we do that? Using this epsilon-N method. So this method which I told you is known as epsilon-N method. Why epsilon? Because epsilon and n, epsilon is a real number and capital N is a number which is bigger than 1 by epsilon, right? I mean, sorry, in this case, 1 by bigger than 1 by epsilon, but yeah, so for every small n greater than or equal to capital N, we need to find. Right? Okay, so we have to show that this limit does not exist, right? So suppose limit n tends towards infinity, Sn is so. Sn is L for some real number L. Suppose this limit exists. I have to show that this limit does not, even though sequence is 1, 2, 3, of course, when you take n tends towards infinity, it will not exist, right? So I have to show that it does not exist, right? So I've assumed that suppose this limit is L, some real number, okay, where Sn is small n here. Okay, I'm just writing this. This means that I just write down the definition. For any epsilon, there is n for which mod of Sn minus L is less than epsilon. For every n that are equal to capital N, right? By definition, I've just written the definition, right? That means for any epsilon, there exists n. Yeah, there exists n. For which mod of Sn minus L is less than epsilon, right? Now, see, another very important thing now, something to be careful. People don't understand why I'm doing this. I have to arrive at a contradiction. This, if limit exists, this should be true for every epsilon. अगर हमको contradiction दिखाना है, why I should worry about all epsilon? I choose some epsilon and for which I'll say that this for this doesn't happen, so it doesn't work anyway, right? So I will take some epsilon value and say that for this nothing is happening working. So of course, if it cannot work for one epsilon, of course in general it will not work, right? I'll take one epsilon, right? So people ask this question: why to take epsilon this? You know, who will suggest what to take? So that comes by observations, right? Observe the beauty and you will get the answer. Okay, so let me show you. Take, because I have to arrive at a contradiction, I can show it for fun some value. So I am taking epsilon is equal to 1. This will give you mod of Sn minus L is less than 1. Right? For every n greater than or equal to capital N. Sn is n. So this implies that minus 1 less than Sn minus L less than 1. This implies that L minus 1 is less than Sn. Is less than L plus 1, where n greater than or equal to capital N. So Sn is n here. That means L minus 1 is less than L plus 1. Now the question is it possible what I have written here? It says that n is bounded. Now that said, I'm saying that as n increases, right? Yeah, so there is a problem here. I've just taken one value of epsilon and then there is a problem. That means this is a contradiction, right? So our assumption that this limit exists does not work. So you need to do practice of epsilon n method for two kind of problems. One, show that this limit exists. Other, show that limit does not exist. I think some of the things are given in your tutorials. You might have started doing this, right? If you need more problems, I can give you tons of problems to work out, right? What you require? Pen, paper, 4-5 दोस्तों की company और चाय cup, right? And just enjoy, right? Okay. So, and the problem I will supply to you, right? Unless you discuss, right, how to arrive at. Okay. So, very important thing, when you want to show that limit exists, you estimate. So actually many people ask, okay, how do we check that limit is there? So we estimate some value. Okay. Some estimation. So of course, you know the value is 0 here, so you put 0 and do the calculation. So we estimate. If that estimate fails, you try another estimate, right? So some estimate you do and then try to show the epsilon n business, right? And in the case of you have to show that limit does not exist, assume that limit exists, call it L, some real number, and arrive at a contradiction for some epsilon. And that epsilon you can choose depending upon what is the function, Sn, right? Accordingly, you will choose. Any question? आप बहुत शांत हो, सब समझ में आ रहा है? Okay. Any question at this point? Question पूछोगे तो सीखोगे, नहीं पूछोगे तो yes. अरे मैं दूर तक आ नहीं पाऊंगा. हाँ, बोलो. हाँ, तो last statement is saying that now n approaches towards infinity, right? So n is greater than or equal to n. So one side it is saying that n is a number bigger than n. You are moving away certain number. Other side is saying it is bounded. How it is possible, right? So it's a contradiction, right? So remember, if you have to show that something does not exist, you have to choose some value of epsilon so that you arrive at some contradiction. And that who will tell you? Observation, right? Will tell you what epsilon you should take. Look at the function and you will be able to guess. Okay, somehow, I mean, in some cases, contradiction is like this, in some other cases, some other thing, right? So that you have to find out from the function that you are looking at. Okay, yes. So that's the definition, right? It's saying that, what was the definition? Small Sn, the sequence moves towards capital L, right? Or in the neighborhood of capital L as n approaches towards infinity. When n approaches towards infinity means for every n is greater than or equal to capital N, means small n, when you are increasing, right? N is equal to 1, 2, 3. Once we fix capital N, after that, all the terms are in the neighborhood of L. A number, a fixed number. For every small n greater or equal to capital N. Okay? It's a number, yeah. नहीं, जीरो है ना बीच में, तुम क्या बात कर रहे हो? Look at it. So what there in 1 by n goes towards 0 means what? Now I am saying that if you take capital N to be greater than any number greater than 1 by epsilon, you can go back, choose numbers, just choose capital N to be say 1 by epsilon plus 1. Go back and you see the answer, right? Everything is beautiful, right? I mean, you cannot put things here and there. Anyway, so these are the two important ideas. I say these are the ideas, right? ये क्वेश्चन का स्वरूप बदल जाएगा, राइट? आत्मा तो वही रहेगी, राइट? कोई और क्वेश्चन आ जाएगा, और क्वेश्चंस की कमी नहीं है मेरे पास, राइट? So anyway, so this is something important. Now let us see what else is left there. Another very interesting sequence is, I should say that I love this sequence. If I say that over a cup of tea, find out whether the sequence has any limit or not. Obviously, it doesn't have a limit, right? As n towards infinity. How will you prove it using epsilon-N method? So that is a good thing for you to do, right? And as you know, I mean, again, that comes from observation. Minus 1 raised to power n, there is an interpolation formula, it is equal to cos n pi. Do you know? Cos n pi, same thing as minus 1 raised to power n, right? So using that trick, you can simplify, all kind of things are possible, right? Okay, so show that this function has, this sequence has no limit. You can do that. I'm not going to do that. I have done 2 examples for you, and I think that is enough. So we say that if the limit of a sequence exists, we say that the sequence is a convergent sequence, right? It converges towards a limit, right? A sequence is convergent if it has a limit. By the way, you are doing a course on electronics also, right? A sequence related a question here, but of course it is not infinite. So suppose there is a resistor of 1 ohm, resistor of 2 ohm, resistor of 3 ohm, and so on, resistor of n ohms, all parallel. What is the effective resistance? You understand my point? 1 ohm, 2 ohm, 3 ohm, dot, 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 n ohm. All n ohms in parallel. What is the effective resistance? Obviously, you know the formula. It will be 1 by R is equal to 1 plus 1 by 2 plus 1 by 3 dot, 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 1 by n. How to sum this? Can you find a compact formula for this? 1 plus 1 by 2 plus 1 by 3 dot, 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 1 by n. Ask your electronics people. I love, this is a bad habit, but I always ask questions, right, which are tricky. Okay, so what is the effective resistance? How will you find a compact formula? See, all these things are beauty of mathematics, and actually, when you focus on the beauty of mathematics, it will enhance your knowledge and you will learn something new about it, right? So this is something interesting anyway. Another definition is bounded sequence. A sequence is said to be bounded. So we say that a sequence Sn is bounded if and only if there exists M, a real number, such that absolute value of Sn sorry, cannot exceed M. Okay? Absolute value cannot exceed M means all the terms lies between minus M and capital M, right? Everything in that interval. It's bounded. Now there is a result, or I will call it as a fact. Every convergent sequence is bounded. A sequence is convergent if the limit exists, right? Okay. Now comes Cauchy, that book Cauchy Analyze. I think if you read, you will enjoy it. He has come up with a alternative definition of convergence of a sequence, and many times, if you want to show that some sequence is convergent, you can use that result. It's a very beautiful result. Okay, so I'm going to mention that result. I'm not giving any proof. All these proofs are very easy, right? You have to digest the beauty, and that's all, so that you can do some things on your own, right? So this is an important thing. Every convergence sequence is bounded. And obviously, again, if you take a cup of coffee, probably you can prove this using this epsilon-N method. Epsilon-N method is a very, very fundamental method, right? So all those formulas that you have studied in your JEE coaching or anywhere else, right? Those can be proved by epsilon-N. If you are a very good mathematician, like Ramanujan, you will start proving everything by epsilon-N, right? So you see your mathematical sharpness will increase, right? All formulas that you have learned in limit, right? You can prove it by epsilon-N method. Okay. So there are a lot of other things. If xn is a sequence, yn is a sequence, their sum is a so xn is convergent sequence, y is their sum will also converge, right? All kind of properties are there, right? That you can derive. Okay. So many things. So anyway, so this every convergent sequence is bounded can be proved easily. I mean, I'm not going to do because see, if you just search on Google, you will find tons of proof of this fact, right? So I have to convey you the important things, okay? Beauty. Anyway, Cauchy sequence. What is a Cauchy sequence? A sequence of real numbers, I say here n is equal to 1 to infinity, is called Cauchy sequence if for any epsilon positive there exists an integer n such that distance between Sm and Sn is less than epsilon whenever m and n is greater than or equal to capital N. So basically, sequence के बीच का difference, I mean the terms, right, goes towards 0, right? So Sn minus Sm. Okay, if you can show this is a beautiful property. In fact, every convergent sequence is Cauchy sequence. Again, you can show that. If a sequence is convergent to Sn goes. If a sequence is convergent, Sn goes towards L, right? So Sm also goes towards L. So mod of Sn minus Sm can be written as mod of Sn minus L plus, L minus Sm, right? So using triangle inequality, I mean, then you, not triangle inequality, you're just expanding. And then each one goes is less than, say, this is epsilon by 2, this is epsilon by 2, the whole thing is less than epsilon. Right. So so I can just mention these two results actually. Every convergent sequence is Cauchy and vice versa. And so basically what I was saying, that suppose sequence is convergent, how do we show this? That So that means Sn approaches towards L. Similarly, Sm also approaches towards L, right? So you have to only worry about the number capital N. How do you choose, right? And then basically you can say that Sn minus Sm. I'm giving you only hint. I'm not proving anything, okay? Minus L plus L minus Sm. I hope now you know what to do, right? You can break these things by triangle inequality, yes. Right. And then choose M and N. So because M is greater than or equal to capital N, N is greater than or equal to capital N, right? You have to arrive at these two small m and n, right? So that the whole thing goes towards this. This is the fact which is very, very important. Right? So this you can, mod of Sm minus. So basically, here, as Sn ends towards L means for every sign positive, you can take epsilon to be epsilon by 2. And the other case also epsilon by 2. So epsilon by 2 plus epsilon by 2 will sum you, give you epsilon. So the whole thing is less than epsilon you can show. कुछ चीजें मैंने छोड़ दी हैं, so I think you will think about it why. So numbers को choose कैसे करेंगे, right? M or N, so that everything makes sense, okay? Any question? And every Cauchy sequence is bounded because every Cauchy sequence is convergent also, it is bounded also, right? So I think this much is enough for sequences. So next class, probably we will see limit of a function. हम लोग बहुत जल्दी जा रहे हैं अब, right? शुरुआत के 3 लेक्चर बहुत ही स्लो फिर एकदम से एक्सेलेरेटर बढ़ा दिया, राइट? सो नाउ यू आर एडजस्टेड टू दिस एनवायरनमेंट, राइट? प्लीज डिस्कस ऑन व्हाट्सएप ग्रुप कैलकुलस मन की बात में आप जो चाहे वो लिखो, ठीक है? ऑफ कोर्स एकेडमिक स्टफ, डिस्कस इट. आई एम वाचिंग ईच एंड एवरी थिंग, राइट? सो ऐसा नहीं है कि मैं if somebody is doing really upset, and don't send me personal messages because others will not be able to know what I am answering, right? So just discuss in the group. Use this group 24/7. I am available. I've asked Sudeep Bera also to be available, right? So post, discuss, right? Make group and study. 4 सितंबर तो आने वाली है, right? नहीं, तुम्हारा तो 18 सितंबर. और sample papers also, 4 questions, beautiful questions you might have observed, right? So I hope you are started searching the Google, right? Every time I give you new question, new paper, absolutely new paper, right? So you will enjoy the beauty, right? 4 questions. Anyway, thank you very much.